So this presentation, this tutorial is going to be addressing our project, our research project, which we've been running at our university in Hong Kong. That's Hong Kong Baptist University. And it's about translation on Wikipedia. And in particular, it's to present the tool that we've been developing that will help to locate, identify pairs of translated sentences in different editions of Wikipedia, or indeed other pairs of sentences that are similar to each other. Now, I say we have developed. In fact, the developer on the project is my co-presenter, Zhilu, who's been working on this project with me, and he will be explaining about the tool in some detail in a little while. He'll be doing a demo. He'll be doing a live demo. So a little bit about our tool. Unfortunately, although the tool is quite well developed, we don't yet have a name for it. So we're going to be calling it our tool, but I'm sure we'll put that right shortly and hopefully come up with a reasonable name. So we're using Python as the development language. As I'm sure many of you are aware, this is one of the most popular programming languages, and it's been gaining a lot in popularity over the last few years. And we've been using the Google Colab platform, which is a platform that allows you to write and execute Python programs in your browser. And the advantage of this is that it does not require any configuration. And then our tool is based on the sentence transformer framework, and this is a framework that provides an easy method for computing dense vector representations for sentences, and this makes parallel sentence mining possible, because ultimately that's what our tool aims to do, aims to perform parallel sentence mining. I'm going to provide a little bit of background about the aims of the project now, of which this tool forms a part. And this is, as you understand, this is an academic research project, although, you know, we're hoping that some of the outcomes from the project will be of use, of value, of interest to people outside the academic community. So our project is called Understanding Wikipedia's Dark Matter, Translation, Knowledge, and Point of View. So as I've mentioned, the project is about translation in Wikipedia. And for those of you who work in English, perhaps you're not so aware of this. Maybe users of other languages might become more aware of the fact that there is actually a large amount of translation in the multilingual encyclopedia, but most of it is not obvious. You sort of suspect it's there, but you don't know where it is, or you don't know how much translated material that is in a particular article until you dig beneath the surface and you try and discover it. And this is why we refer to translation in Wikipedia as dark matter. You know it's there, but you're not quite sure exactly where it is or how much of it there is. So our project focuses in particular on analyzing multilingual sets of articles, and in particular ones that track news stories, and ones that news stories that are developing rapidly. And that obviously generates a large amount of editing activity. And as we found, quite a lot of cross-fertilization and cross-referencing between the different versions of the article in different language versions of Wikipedia. So we have a project blog for those of you who are interested, and there's the URL, and we'll put the URL up again at the end of the presentation. And I think it is only right and proper to acknowledge the Hong Kong University Grants Committee for kindly funding our project. So what we're setting out to do in the project, these are the, in a slightly abbreviated form, these are the project objectives. So we're working on we've had an interest in particular, I suppose my interest in Wikipedia translation has gone back a number of years. And we've done this before manually, which is not easy, identifying translated material manually in Wikipedia. So we're aiming to develop that research methodology, and also to carry out one or more additional multilingual case studies. I have previously performed a couple of these, but maybe supplement those with one or two more. And in particular, to look at the location, nature, and development of translated material in Wikipedia. And although this is not the subject of our presentation today, to see how it contributes to point of view, the point of view advanced in a particular language version of an article, and see how, first of all, whether we can talk about one particular article having a single point of view, or given that it's almost always going to be the product of multiple editors, whether you can distinguish multiple points of view in a single article, and also how the points of view in different language versions differ with each other. Because of course, as you're all well aware, the official policy of Wikipedia is to pursue a neutral point of view strategy in developing an article. And of course, this is a very laudable aim, but in a sense, it's an aim that's impossible to fulfill completely. And what we find is that the points of view, political or otherwise, that are put across in different versions of a single article might vary quite considerably. So we're going to hoping to extend the research into new areas and contribute what we can to what is known about translation in Wikipedia, because, I mean, let's face it, everybody uses Wikipedia. I find myself as a teacher encouraging my students not to refer to Wikipedia too much and not to put it in their bibliography, but at the same time, I quite happily use it on average, several times a day for my own purposes. So given that it's such an important source of information and understanding for so many people, I think it's only right to try and be as aware as possible of where the information comes from, and therefore what its status is. And that, I suppose, is the ultimate aim of our project. So we're on to point 5 now, objective 5, and this is to produce new digital tools for research and visualization, and to make these publicly available. So I suppose what we're focusing on today is what is likely to be the main digital tool that will hopefully emerge from the project. We're also hoping to make some of our data sets publicly available for anybody who is interested. And as I've mentioned, there's also a project blog. Okay, so some of you may be wondering why another tool? There are so many tools for the study of Wikipedia and for researching Wikipedia. I personally adhere to the idea that if you're researching Wikipedia, you should use Wikipedia to do so. There is so much information on Wikipedia, in Wikipedia, about itself. And also the encyclopedia makes numerous tools, research tools available for you to use. And we do indeed make use of quite a number of these. Some of them are produced by Wikipedia itself. So via the research history page, you can get to page view statistics. And there are about 8 or 10 different tools there. And we tend to use lang views and site views as the main tools that we refer to, and they give some very useful statistics about the page that you're interested in, the article that you're interested in, and then also revision history statistics, and indeed the revision history page itself gives some incredibly rich information about the page you're looking at. As you're all aware, a Wikipedia article is always a work in progress. And every time somebody carries out an edit, a new version replaces the previous current version, and that previous version then gets archived along with all the other previous versions. So when you're looking at say an article about a significant international news story, that may undergo literally thousands of edits, and each one of these will be archived and can be accessed. There's also, some of you may be aware of WikiWho, which is a kind of add-on tool that you can implement if you're logged in as a user on Wikipedia, and that will allow you to highlight the text in an article that has been produced by a particular editor, and that can be quite useful for tracing back, for attributing, who said what, who edited what in a particular article. And then there's one, once again, this is accessible via the edit history page. It's called Wikiblame, and we use Wikiblame quite a lot. And it allows you to find the first use of a particular word in the history of an article. And I've certainly made a lot of use of this over the past years. So a particular keyword, or maybe a person's name, you can find that was added on a particular in a particular edit, and of course the edit is time-stamped to the nearest minute. And then that's useful for translation research, because once you've found what seems to be a translation pair, a source sentence and a target sentence, you can then find out which of them was added first. And then you can be absolutely sure, for example, that a particular sentence was translated from English into Russian instead of from Russian into English, and so on. So what I have discovered in the past is that discovering these translation pairs by hand is incredibly time-consuming. And it's painstaking work, and you building up a set of translation pairs that you can then analyze and try and work out what's going on and what kind of a point of view is being advanced, and what the role of translation is in developing or maybe challenging that point of view. It takes a long time to achieve all of that. So in developing our tool, we've been hoping to produce something that will take the sweat out of this task. And the way it does this, as you'll see shortly, it generates sets of candidate source target sentence alignments. And we do believe actually that it does seem to be moderately successful in terms of making this whole process more streamlined. So just to mention briefly in passing, there are other tools that we have been working on. There's one which we call WikiTime. which is intended to track the intensity of the editing effort over time. And then we've been working on a development of Wikiblame called multi-Wikiblame, which will allow you to do what I described previously, but in more than one language at the same time. Okay, so moving on. This is just to give you an example of how we used to have to work. This is a pair of sentences. It's a number of years old now, and it comes from an incident which took place in 2015 when a former Russian agent who was living in the UK and who was also being visited by his daughter at the time. They were, so it seems, poisoned by agents of the Russian government. And this was, reported widely in the international news, obviously, and it was also chronicled on Wikipedia with more than a dozen different versions of the encyclopedia devoting articles to it. So what we have here is a pair of sentences, and the Chinese is pretty much in line with the English, and yet we had to identify this pair manually. And as you see from the bottom of the screen, these are sort of micro screenshots from the two page histories, and those pinpoint the exact edit, or rather the exact time at which the edit was made that included the sentence in question. And as you can see here, and I've spelled it out on the right-hand side of the screen, the Chinese, I suppose not surprisingly, given that the events took place in the UK and so on, the Chinese was added a fair bit later, maybe about three weeks after the English sentence was added. Okay, so now let's move on and look at our tool, or rather at some output from our tool. So I mentioned that it could be used really for two purposes, at least two purposes within the context of Wikipedia research. One is for identifying interlingual matches. And then the other one, as we'll see in the next slide, will be for comparing versions of sentences across two previous versions of the article. But here we see the article. We've got the article on Steve Jobs, the English version, and the what should we call it? The standard Chinese, the Mandarin version of the article as well. Okay. On the left-hand side, we've got the kind of accuracy score, and the accuracy score obviously, reflects the level of confidence of the tool that the two sentences are indeed correctly aligned. And 1.7 is pretty good. In fact, most of these are pretty good. The score, as a general rule, scores anywhere down to 1.04, 1.05, something like that, tend to be reasonably reliable. And this is, broadly speaking, the case, although you do see there are some sentences which aren't translated at all, like the third sentence, and obviously that comes out as a very high quality match. But if you go halfway down to the sentence "we shook hands," you actually notice that the Chinese is quite clearly saying rather more than just we shook hands, and that is indeed the case. It's providing a much more detailed scenario there. So that perhaps is not a particularly good alignment, but that is probably an exception most of these alignments are fairly good. So that's a screenshot to show the output from our tool when we're searching for interlingual translation pairs. Let's go on to the next slide now. And in this slide, we can see how the tool works when we're aligning two previous versions of the Steve Jobs article. And we've deliberately selected here less good quality matches, and also, if you'll notice, we've ordered them in increasing or in order of increasing accuracy rather than decreasing accuracy, as was the case in the previous slide. And at the top, and this was 1.0063, and that's slightly below what's, as I mentioned, what we generally take to be a kind of threshold for reliability, which is 1.04, 1.05, and that really is not a successful alignment at all. Maybe as we go down, we start to see some slightly better alignments coming up. And if we went right to the bottom, because it's arranged in this order, then we would see very good alignments. And in this case, a good alignment would be a sentence that has not been edited in between the two previous versions of the article. Whereas a bad or a less good alignment, less accurate alignment, would either imply that it's the same sentence and has been edited in some way, or else it's simply the tool has got it wrong and has inappropriately aligned a pair of sentences that are in fact unrelated. Okay, now let me go on to the next slide. And here, just for the sake of comparison, we've got our tool on the left-hand side, and on the right, this is the comparison tool that's made available as part of the revision history page for every article. Okay, so they do look rather different, perhaps, and ours works with plain text, as you'll see, and then the Wikipedia native one works with wiki text, and I suppose in quite a graphic way it does display the changes, whereas our tool puts the best alignments right at the top. So I suppose depending on what your interest is or what your purpose is, you could possibly use the one or the other. But obviously what our tool does and this one doesn't is it allows you to do interlingual alignment.
And hi there, this is Zhilu, and let me introduce our tool in detail. Now, before we get to the demo, let me have a brief explanation about how the workflow of our tool first. As a matter of fact, there's a similar project called MultiWiki, which basically aligns all the language data from Wikidumps. So the alignment data they provided is enormous and static. On the other hand, our tool's alignment searching is based on articles level, which means it's basically a query system for users to find similar sentences with specific articles. It could be the latest versions or the revisions of the article. So the size and type of data is controllable. And that's the reason why we are using Wikipedia's API to fetch data here. With the help of MediaWik's API, users can have access to the articles they want to do the alignment with. If users want to find alignment based on the latest version, they will just need to type in the article's name, and the text extras API will fetch the plain text of that article automatically. However, bear in mind that text extras API only allows access to the current version of the article. If we want to get the revisions of the article, the revisions and the past API will be the right API to get the historical content. For these APIs, we will need to input the old ID of an article to allow these APIs to fetch that certain historical version. That said, the output of these APIs will be wiki text, which means a hypertext markup used by Wikipedia. So we will need to further parse it to plain text by using an appropriate parser. That's a part of the data cleaning. So if the data is fetched by the text extras API, which means the output will be plain text, then we can skip the parsing and go to sentence segmentation. For Asian languages, I'm currently using regular expressions to split the sentences. For European languages, SyncTalk has proven its effectiveness when dealing with different punctuation systems, and that's the part of data cleaning. When we have the clean file ready for text mining, which means we have the plain text that is split by sentences, we can directly go to the text mining part, which is based on NLP techniques. Here we use a Python framework called sentence transformers. To be honest, I'm not a professional AI programmer. As far as I am concerned, the sentence transformers come with a language model called LABSE, which can somehow calculate the distance between two sentences in a vector level and make the similarity search possible. With two files here, no matter if they have the same or different language codes, we can easily find a similarity between them with the help of sentence transformers. Now I would like to show you a brief demo of our tool in the Colab. I'm sorry the code of this demo is not available yet, as we are still refining the program and getting ready for deployment. But we will make sure the program will be available for the public in due course. So as you can see from the demo, the whole program is based on Google Colab, which provides users with a purely online program experience. On top of that, the Google Colab also supports GPU computing, which can boost the performance of sentence alignment. So to start with, let's make sure the Colab has been switched to GPU mode. We can go to the runtime setting of the Colab and change the hardware accelerator to GPU. And let's save the setting. Now the Colab is connecting to Google's cloud computing platform and running our program remotely. The first step of the demo is to install requirements for the virtual environment. As the Colab cannot save the progress of virtual environment, we need to rerun these steps every time when we want to find the alignment. Okay, so the program starts to installing those requirements from the cloud, and it may take a second or so. Okay, now we've finished the first step, and the second step of the program is to import the utilities functions used to find parallel sentences. This step is adapted from the application of parallel sentences mining under the Python framework sentence transformers. The necessary utilities will be imported instantly if we successfully ran step 1. Okay, now we finished it instantly. And the third step is to get the content from Wikipedia. The main method of scraping data here, like I said before, is to use Wikipedia's API. Together with Wiki text parser and other useful Python libraries, this step can get decent plain text from Wikipedia with a user interface. I would like to show you the interface step by step. Okay. So first we need to confirm the language codes for the alignment. Here I take English and Chinese for example, so I can just type EN and ZH. And here the program asks if we want to analyze the revisions or not. If I choose yes here, Y here, we will need to type the old ID for data fetch. If we type no here, we can have a fuzzy search first and then get the current version of this article we want to analyze. So let's try to align the current version of an article first. Now we can just type the keywords to locate the article we want to do the alignment with. Say we can type Steve here, and we can choose the third option, Steve Jobs. Since we already typed the language codes beforehand, then the program will fetch the latest English and Chinese version of the article. And just a moment, let's see if the article has been correctly fetched in the file system of Colab. Let's reopen the file system of Colab. And we can see two files here. Let's have a quick look at these files. Okay, we can see the article of Steve Jobs has been correctly fetched in English and Chinese. Because the Colab, let me close these windows first. Because the code that the sentence transformers provides only supports alignment on a sentences level. So after fetching data, we will need to split these articles into sentences line by line. And that's the reason why we have to split the sentences with SymTalk. After finishing the step 4, we will find two newly generated files called speed1 and speed2. We can also have a quick look at them to make sure they are splitted in sentences. And here comes the final part: perform bytext mining. If we all did properly in the previous steps, we will just need to click on the final cell and have a cup of coffee before we have the result. So if it's the first time to run this cell, the sentence transformers will download some requirements for the alignment process. Once it's done, we don't need to download them a second time, as long as the Colab session is still there. We can see the downloading bandwidth is quite impressive here. And that may be because we are using Google's bandwidth resource remotely. So it may be faster than your real network bandwidth. So it's still downloading and it may take some time. So after downloading the requirements, now we are at the alignment process. Because we are using the GPU computing power, as I said before, so we can have a very efficient alignment speed here. When the alignment process is done, we can see a brief report has been printed out. It shows how many sentences have been found in the file we provided. Okay, and finally, we can check the output file via the file system. We can see the sentences have been sorted by the similarity index or the quality index. And normally, the threshold for the translation will normally be around 1.04 or 1.05. And the threshold varies between different articles. And we have to manually locate it translation even after finding these alignments. It's also noticeable that some translation fragments will be hidden behind a very low similarity index. Those fragments could be vital for the analysis of the dark matter in the translation. And if we want to do further alignment search, we can go back to step 3 and try to compare the similarity between different versions. So now let's go back to step 3 and try to compare the similarity between different revisions. Okay, this time we can have an intralingual alignment. Let's make both language code 1 and language code 2 as English. And choose yes when the program asks if we want to analyze revisions. And then let's find the old ID of the article we want to analyze. So here I have an example. There's 2 revisions from the English article of Steve Jobs, and one from 2018 and one from 2021. And let's just copy the old ID to the program. And now the program starts to fetching the historical content of Steve Jobs. And we can also have a quick look. Since it's passed by the Wikitest parser, so we might see some difference between the plain text that the text extracts API provides. And then let's speed the sentences with syntax. Okay, now we have the 2 speed files here. And then we perform the bytetext mining. Okay, the alignment process now is done. And let's see, we have the English to English alignment, which in a sense we can notice the similarity. We actually have shown the result beforehand, and that's all for the demo. Thank you very much.
So what are our future plans? The project still has a certain amount of time to run. And as I mentioned at the beginning, we are planning to make the tool available at some point in the future, in the not too distant future, we hope. So we're getting ready to make it available on an open source basis. And at the moment, you know, there's still a certain amount of work to be done. We have somebody who is working on a front end, and then the back end and the front end will need to be married up. And then at that point, I think it will be hopefully more or less ready to share, to make public. And of course, it needs to be deployed on a server. And then for extra, we have ideas for extra features that could be added. And one thing is the addition of highlighting, so that if you move as you move your pointer through one or other side of the alignment, or one or other text, I mean, the alignments will be highlighted. Those of you who are aware or familiar with the WikiWho tool will have an idea as to how that might work in practice in real time. The relevant sentence pair will be highlighted. So a couple of conclusions. Well, as I hope I made clear, particularly towards the beginning, there is a lot of translation in Wikipedia, although it's not always clear how much there is and indeed where it is, and it can be very difficult and time-consuming to locate. So our alignment tool will hopefully improve the situation by automating some of this process. And as we've been explaining, the intention is to make this tool publicly available to be used by anyone who feels it would be useful. And we're aiming to do that in due course. So here are a couple of links to relevant sets of code. And it remains only to thank you very much for your attention. Thank you very much for listening.